Millions of people stepped outside their homes this year and saw something strange. Glowing rivers of neon green and purple light were dancing in the sky. They appeared in places where northern lights never usually happen. People saw them on the beaches of Florida. They saw them across southern Europe. It looked like pure celestial magic. But this light show was actually an urgent warning. It came from a cosmic monster 93 million miles away, our own sun. Every 11 years, the sun reaches solar maximum. Deep inside the sun's core, a massive magnetic dynamo twists and churns. It winds magnetic field lines tighter and tighter, just like a stretched rubber band. Eventually, these loops tangle so violently that the sun's magnetic poles completely flip upside down. When those magnetic lines snap, they unleash coronal mass ejections. These are massive cosmic explosions. They blast billions of tons of magnetized plasma into space at 5 million miles per hour. When this plasma wave collides with Earth, it compresses our planet's magnetic shield. Analytically, this generates invisible ghost electricity deep inside our planet's crust. Thousands of miles of metal power lines act like giant antennas. They suck in this direct current energy and channel millions of extra volts into city grids. In theory, this ghost power can melt massive substation transformers. It can trigger continent-wide blackouts in less than 2 minutes. So here's the big mystery that puzzled millions of people after watching the news. If solar storms can destroy our electrical grid in seconds, why did your light stay on? Why did your smartphone stay charged? Why did the internet keep running? Why hasn't human civilization collapsed into darkness every time we see auroras? The answer is not that solar storms are harmless. We survive because of hidden cosmic geometry, deep space satellites, and smart engineering. The first line of defense is a cosmic quirk called the magnetic keyhole. Earth is essentially a giant bar magnet. It is surrounded by an invisible protective shield called the magnetosphere, with field lines pointing north. When a solar storm arrives, its damage depends entirely on one single variable. Which way is the storm's magnetic field pointing? If the solar storm points north, it matches Earth's field. Just like two identical magnets, the two fields violently repel each other. The solar plasma bounces harmlessly off Earth's shield and slides around our planet like water around the submarine. We get spectacular lights in the sky, but zero electricity ever enters the ground. But if the storm points south, what scientists call negative BZ, disaster strikes. The opposite magnetic fields lock together like puzzle pieces. Scientists call this magnetic reconnection. It acts like unlocking a cosmic front door, dumping billions of volts straight into our power lines. Analytically, most recent storms happen to hit with northward magnetic fields, sparing our grid from damage. Second, even when a storm points south, humanity is no longer flying blind. We have Sentinel satellites stationed 1 million miles in space at a gravitationally stable point called Lagrange Point 1. These satellites include NASA's DSCOVR and SOHO. When a solar storm flies past, their sensors measure its speed, density, and magnetic polarity in real time. This gives space weather scientists a 15 to 45-minute advance warning before the wave slams into Earth. That 30-minute warning is all power grid operators need to take defensive action. The moment a severe storm alert flashes, operators reduce power line loads to 60%. This leaves plenty of headroom so the extra solar surge doesn't melt the wires. Next, engineers reroute power through shorter local transmission lines because longer lines absorb far more ground voltage. Finally, modern substations are equipped with direct current blocking neutral capacitors. These act like electrical shock absorbers, dumping raw direct current into grounding rods before it can destroy million-dollar transformers. But make no mistake, when a storm is large enough, our defenses can still fail. In March 1989, a solar storm struck Canada. In less than 90 seconds, 5 major power lines tripped and transformers melted. 6 million people were left in freezing darkness for 9 hours. And in 1859, the legendary Carrington event unleashed a superstorm so intense that telegraph wires sparked and caught fire. Operators continued sending messages across America with their batteries completely disconnected. If an 1859 scale superstorm struck our modern world today with a southward magnetic field, it could disable GPS navigation, it could fry undersea internet cable repeaters, it could burn out transformers that take years to replace. So the next time you see auroras glowing in the night sky, remember the hidden truth. You're not just looking at pretty lights, you are watching Earth's invisible shield fighting a real cosmic battle to keep our modern world alive.